Hi, I'm Darren and welcome to Level Up EE Lab. Well, I have finished integrating my transmitter with my homemade receiver, and today we're going to take a look at how they work together along with wrapping up this project and talk about things that went well and things that didn't go quite so well. Let's check them out. Earlier in this series, I explained that I would be interconnecting this transmitter to my simple HF receiver. It's what I've been calling the Captain and Minion operating modes, which among other functions means adjusting the frequency on the Captain will simultaneously adjust the frequency on the Minion so that they stay in lockstep. The hardware that enables this operation is the MAX3232 line driver. I already showed in episode 16 exactly how I integrated it into the transmitter. Now to complete the loop, I need to also install a companion MAX3232 in my simple HF receiver. Rather than whip up a new circuit board, the quick and dirty hack here is to cut the appropriate segment out of one of my extra transmitter main boards, and here's what that segment looks like. It's the portion that has the MAX3232 and all of the charge pump and filter caps that go along with it. Installing this segment in the receiver, however, isn't quite so easy. I need access to the bottom of the main board. And to get to it, a bunch of other stuff has to come off first, like all of the knobs, the control mounting hardware, the bezel, and the front panel graphics. After I loosen the audio board and bend it over to the side, I can finally access the main board mounting hardware. Getting this assembly out of the case requires quite a bit of wiggling and also bending the case open a little bit. But no worries, it came out with no damage, and bending the case back to square is easily done. And while I have the receiver completely torn down, now is the ideal time to install the connector for the interconnect cable. This way I'm not getting any metal shavings into the electronics. Okay, finally I've got unobstructed access to the bottom of the main board. I need to solder connections from the Arduino TX and RX pins to the corresponding connections on the MAX3232 board segment. That's the orange and yellow wires you see here. I also need structural support for the board segment, and here's a simple little bracket that I designed and 3D printed. It aligns with the existing main board mounting hardware. The board segment just slides into it with a slight friction fit. That's all it needs. It's trapped once it's installed. Here's the board segment in place with all the other electrical connections made and 3 bandpass filters plugged in. See this little guy here? That's a 10 microhenry RF choke. I added that after I powered up the receiver and noticed that the switching noise from the charge pump was interfering with reception. Also notice that just like in the transmitter, there's a pair of jumpers here too, so that I can isolate the Arduino from the MAX3232 whenever I need to reprogram it. Here's the interconnect cable that I fabricated to go between the transmitter and the receiver. This end right here plugs into the jack right here on the receiver, and then this end here plugs into this jack on the transmitter, and I've got this extra pigtail here that I'll talk about in a minute. Now this is an 8-conductor shielded cable, but I'm only using 4 of the conductors. 2 are for plus 12 volts DC and ground, which I feed from the 12 volt power supply in the transmitter to the receiver, so I don't need to connect up external power when these 2 are working together. And the other 2 cross connect the TX and RX pins between the 2 Arduinos. And I say cross connect because functionally this is very much like an Ethernet network crossover cable, meaning the transmit signal on one end is connected to the receiving on the other. And then back to this pigtail. So this is just a little breakout segment here with a 1/4 inch phono plug, very conventional old style connector. And this is where I can plug in my key in order to key the transmitter for sending Morse code. All right, let's do a quick demonstration of the Captain Minion mode. I've got the transmitter and receiver connected to each other using that crossover cable. I've also got a cable going from the antenna output of the transmitter to the antenna input of the receiver. And then of course, AC power going to the transmitter. So let me turn on the transmitter and it'll go through a few seconds of boot up. It's right at the bottom of the 40 meter band. I'll turn on the receiver. You can see it's at the frequency where I had last powered it up, and they're in split mode right now. So as I tune the transmitter, nothing happens on the receiver. Tune the receiver, nothing happens on the transmitter. So let me switch this to Captain mode now. And now, so you can see as I tune the transmitter, the receiver's following right along. So, pretty strong CW signal there. So that's how the Captain and Minion mode works. At this point, I consider this project complete, and I want to spend the rest of this episode doing some reflections on its performance, both the good and the not so good, and talk about some plans I have for the future of this transmitter. So let's start with the list of the good things, and first and foremost, I did achieve all the major goals that I set out from the beginning. I hit my 20 to 30 watts output target. I'm able to transmit CW and sideband on multiple amateur HF frequencies. I did incorporate the Arduino and the SI5351 without any headaches, and it works seamlessly with my simple HF receiver in what I've been calling Captain and Minion mode. Now, I did drop the switchable filters early on to save on complexity, but I did upgrade to internal DC power so it can run on regular 115 volts AC. Another win is the overall appearance, starting with the case. It was the perfect choice from a cosmetic standpoint and overall size. It's just big enough to fit all the internals and still have enough room inside to work on without being excessively large. I'm also happy with how the front and back panels turned out. There's a bit of minimalist approach with this design, just enough controls and connectors to make it functional. And I do think the ability to orient it 4 different ways will turn out to be a nice plus too. Third, my system architecture and the individual building blocks that I use for the transmitter stages all pretty much worked immediately on first bring up. The only real exception was the RF preamp, and that took several spins to get it working. But considering just how many stages there are in this transmitter, I think that's a pretty good batting average. Of course, I was leveraging a lot of proven designs from EMRFD and other sources. That always helps the chances of a project working. Now let's talk about some of the not so good things that just didn't turn out as well as I'd hoped. The first one and the biggest one is time. This project just took way too long. I've been working on this for about a year now, and it's kind of my own fault. I let other projects jump ahead of the line and worked on those until they were completed, and that just kind of happens with hobbies. Sometimes things are more interesting and you get distracted, but the consequence is having to pick back up where you left off and not maybe remembering what to do next, and so there's a lot of inefficiency there to kind of recreate lost work. The remaining not so good items are all performance related, starting with poor third order IMD. My crude measurements in the prior episode shows I'm only about 23 dB down for the third harmonic, which is not good by today's standards. Next, the audio and sideband mode is noticeably missing the low frequencies of my voice. One viewer did comment on that, and in fact the only QSO that I've made so far with the rig, more about that in a minute, that was the immediate feedback that I got from the ham on the other end. Not having those frequency components in my speech hinders my ability to punch through crowded conditions and be heard through atmospheric noise. And speaking of punching through, this power output is just too low to be of practical use at my location. For sure, 20 to 30 watts is nothing to sneeze at and is way above QRP levels. But what hinders me the most is my antennas. I just don't have the space to put up a proper 40 meter dipole, and even my 20 meter and higher band dipoles are space compromised. So until I can solve my antenna problems, a lot of my transmitted power just isn't getting very far. I had really hoped to show some video in this final episode of me making some QSOs with this transmitter, but I tried multiple times on 40 meters and 20 meters over the past couple of weeks, and I was just only able to make one QSO. So that kind of shows the combination of the low power and the problem I have with my antennas. It's just difficult for me to get out there. Now, like a lot of my fellow engineers, I can't leave things alone without thinking of ways to improve them, and this guy is no exception. I do have a few ideas I'm kicking around for future improvements, starting with the audio. I'm thinking of changing the microphone preamp from the simple 4416 FET and NE5532 amp that's in there now to the more sophisticated Max 9814. Now this is a dedicated microphone preamp chip that has a really nice bonus, automatic gain control. I don't have AGC in my present design, and that makes it difficult to set the drive level high enough without overdriving on voice peaks. And with this change, I should be able to boost the lower frequencies to help address that issue too. Next up is to trace down the source of my high IMD. I'm suspicious that most of it is coming from the RF preamp because I'm running relatively high currents through those two 3904s and two N2222s. But at any rate, I've got a new toy here in the lab. It's a Tiny SA Ultra, which has a resolution bandwidth as low as 200 Hz, so it should be able to make adequate measurements. But whatever's causing it, I'll take a stab at improving it. Another simple improvement I'm thinking of making is to make this side panel hinged with a latch on it, so that it's much easier to open it, get to the filters, and close it without having to take off 6 screws and put them back in again. And you may even be able to see on video, I've only got 2 of them in there right now because it's already kind of a pain to be in and out of the thing with 6 screws. The last item on the future wish list is more power. When I decided to go with this dual IRF 510 design, I was nervous because I'd never built an RF power amp before, and I wanted to stick with the design that was well characterized. But since then, I've been looking into the much more powerful MRF 101AN. Now that's a true RF MOSFET, and there's a growing body of design work on the internet about applying it to amateur HF use, so it's a logical upgrade and can easily get me to the 100 watt level. So in closing, this was an immensely satisfying project for me to work on, and I hope you guys enjoyed all 19 of the episodes that I put together on this over the past year and got something out of it too. This was a great opportunity for me to learn a lot more about transmitters and to exercise my skills in mechanical design and electrical design and construction. Now, I will be making available on my new blog site, and you'll see the address at the bottom of the screen here, and I'll also put it in the video description as well. I'll be putting on that blog site shortly the source code for all the software for you guys to study if you are interested in seeing that, along with details on the circuit schematics and other portions of the block diagram for the entire transmitter, so you can study that material as well. As always, I thank you very much for watching my channel, and until next time, bye for now.